Let's talk about solving second-order differential equations with Laplace transforms. Using Laplace transforms, solve the initial value problem y double prime plus 4y prime plus 3y equals 0. Y of 0 equals 1, y prime of 0 equals 6. We start by finding the Laplace transform of each side of the differential equation. So we've got Laplace transform of y double prime plus 4y prime plus 3y equals L of 0, Laplace transform of 0. We're going to use these formulas for the Laplace transform of derivatives. Okay, so this is what we end up with. Laplace transform of y double prime is going to look like this. 4 times the Laplace transform of y prime, that looks like this. We've got 3 times the Laplace transform of y. And then the Laplace transform of 0 is just 0. So when we substitute in 1 for y of 0 and 6 for y prime of 0, this is what we end up with. Again, y of 0 makes another appearance here. Plug those in, and then let's distribute and simplify. So s squared y of s minus 6 plus 4s y of s minus 4 plus 3y of s equals 0. Factor out the y of s, and we end up with this. Get the s plus 10 on the other side, and then we have y of s times s squared plus 4s plus 3 equals s plus 10. So this is what we have from the previous slide. Let's divide both sides by s squared plus 4s plus 3, and we've got this. So now we just need to find the inverse Laplace transform of each side. But first, it would be much easier to solve if we broke this up using partial fractions. S plus 10 over s plus 3, s plus 1, again, can be written as a over s plus 3 plus b over s plus 1. Multiply both sides by the denominator, s plus 3, s plus 1, and we end up with s plus 10 equals a times s plus 1 plus b times s plus 3. So let's plug in strategic values for s, like s equals negative 1. When we do that, then s plus 1 is just 0. So we get 9 plus a times 0 plus b times negative 1 plus 3. In other words, 9 equals b times 2, so b equals 9 halves. In the same way, let's plug in s equals 3 to find out what a is. We do that because then this factor is just 0. So we end up with 7. In other words, negative 3 plus 10 equals a times negative 3 plus 1 plus b times 0. We have 7 equals a times negative 2, so a equals negative 7 halves. Great. So we've seen that you can rewrite this fraction as a over s plus 3 plus b over s plus 1. In other words, negative 7 halves over s plus 3 plus 9 halves over s plus 1. So this is what y of s looks like. Y of s equals this fraction. In other words, it's going to be negative 7 halves over s plus 3 plus 9 halves s plus over s plus 1. Okay, we take the inverse Laplace transform of each side, and this is what we end up with. The inverse Laplace transform of y of s, well, that's just going to be a y. That's easy enough. So we're going to have a y here, y here. We have negative 7 halves times the Laplace transform of 1 over an inverse Laplace transform of 1 over s plus 3 plus 9 halves times the inverse Laplace transform of 1 over s plus 1. We've seen before this can be rewritten as e to the negative 3t, and that's e to the negative t. And so that's our answer. Y equals negative 7 halves e to the negative 3t plus 9 halves e to the negative t.